Okay, hello, my name is Scott Grizzard. This is Calculus 1, spring of 2021, from the University of South Florida. Tonight, what we're going to do is we're just going to go over, but given that I've seen this mistake a couple of times, and it's okay to be making this mistake now, let's fix it. So this is just a review of the algebra of fractions and some of the tricks to deal with them. Now, I'm not saying that you don't remember how to do these things. Most of you do. Most of you can do it abstraction. But, algebra is an unnatural act. So, a lot of times, especially when you're dealing with just symbols, you kind of forget the rules, right? Because you don't use them every day, and it's just not something that you keep doing and doing and doing. So what we're going to do is we're just going to go over just some of the rules and how we tackle problems. And the motivation for this is that this problem right here, okay, so we're going to talk about this later, but here's the definition of the derivative, right? If f is a function, then f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. That's just the definition of the derivative. So it's a limit. So we're going to want to take, we're going to want to let f of x equal 1 over x, and we're going to want to take the derivative of 1 over x. So we're going to want to compute the limit as h goes to 0 of 1 over x plus h minus 1 over x all over h. How do we feel about that, 1 to 5? I'm not sure if anyone's watching. If that's okay too. I mean, it is a review of fractions. And for some reason, the polling's not working. There we go. One of the polls is not working. The other one is. Okay, so all we want to do is we just want to just review some of these rules. Okay. Now, here I've got a fraction. I've got a subtraction of two fractions on top of another fraction. Okay. So the first thing I'm going to do is I'm going to deal with this h on the bottom by multiplying it by making it a 1 over h to be done. And the way to think of it is this. I've got a, so here's the kind of thing I have going on here. So let's say I have 1/2 over 6. Okay? In other words, what I have, I'm going to take 1/2 and I'm going to divide it into 6 pieces. Or I've got a over b all over c. Now, the important thing to remember is this thing is actually division. So this is really a over b divided by c. Now, if we remember this rule, we simply go 1 over the reciprocal, and we wind up with a over b times 1 over c. So when I do this 1 over 2 over 6, that is the exact same thing as 1 over 2 times 1 over 6. Okay? So here, when I do this, I'm going to do this bit here. I'm just going to move the h over by just multiplying by its reciprocal here. I'm going to keep that grouped. Okay, so 1 to 5, how do we feel about that? Oops, that's not working. So all I'm doing is I'm just treating this I'm just going to get rid of this compoundness in the fraction, so I just don't have to deal with it anymore. Okay? Now, you don't have to do it this way. I can do it with the top first, but I just find it looks nicer. Now, the next thing I'm going to do is I'm just going to take a common denominator here. So remember when I wanted to subtract 1 over 8 plus 2 minus 1 over 8, what I would have to do is I'd have to take a common denominator here. So this would actually be 10, but I don't really know it's 10 yet because I have a variable here. So what I'm going to do here, remember common denominator. So if I thought about this as 1 over 10 minus 1 over 8, the common denominator aspect would be obvious. But I'm just going to think about this as 8 over 2. So what I'm going to do is I'm going to multiply both sides. I'm going to multiply this by 8 over 2 over 8 over 2, and this one by 8 over 8. So I'm going to wind up with 8 over 8 times 1 over 8 plus 2 minus, and then I'm going to multiply by 8 plus 2 over 8 plus 2. and you want to make it 10, but the reason I'm doing that is just to show you that it's the exact same thing. And now I have a common denominator I can do that with. Well, here I've got the exact same thing. It's just a common denominator. So I'm going to do the limit as h goes to 0. And I could have chosen something smaller, but the only reason I could have chosen something smaller is I actually happen to know that that is 10. Right? I could have chosen something smaller. I could have chosen, because that will factor, right? The q is common in both. But I don't know that here. So what I'm just going to do is I'm going to multiply the first bit by x over x. So this becomes x over x times x plus h minus, this will become x plus h over x times x plus h. And then remember, I'm still multiplying by 1 over h. 1 to 5, how do we feel about that one? Okay. Now, here's a tip. In calc, leave things factored. Okay, this is factored. I'm just going to leave this. And remember last time when I multiplied by the conjugate, I left one of the terms factored, and I only messed with the one with the other square root. And it's the same thing here. I'm just going to leave this factored. This x times x plus h. But it's a common denominator. So what I'm going to do next is I'm going to do lim h goes to 0. I'm going to carry around that baggage. And now, because I've got those terms, I'm going to combine the terms. So this is going to be x. Now, this minus needs to be distributed all across the top. So I'm going to do minus x plus h all over x times x plus h. Times 1 over h. And then, once I distribute that, I'm going to get the limit as h goes to 0 of x minus h all over x times x plus h times 1 over h. Okay. Now, I've got an x minus x, that equals 0. Here's a tip. Only do one type of cancellations at a time. Okay? So I know now that this h is going to cancel there, but I want to be careful. I only want to do one type of cancellation at a time. Okay? Right, so these all go to 0, and now those will cancel to 1, but not until this goes to 0. And I want to break that up into a separate step. So now I have the limit as h goes to 0. I've got on top of here, I've got a negative h. On the bottom here, I've got an x times an x plus h times an h. Now I'm going to cancel the h's. Both of those go to 1 because it's a multiplicative canceling. And then I'm going to wind up with the limit as h goes to 0 of negative 1 over x times x plus h. Now I'm going to do a direct substitution. So this bottom is going to go to x times x plus 0, which equals, the 0 goes away, obviously, and I wind up with x squared. So this, after a direct substitution, winds up being negative 1 over x times x plus 0, which equals negative 1 over x squared. Okay, 1 to 5, how do we feel about that? And are there any questions? And as I said, this is just, it's supposed to be a reminder of how to do these things when I wind up with these abstract things. Now, I got rid of the h at the end by taking the limit. So when I had h goes to 0, I substituted in the h, and that's what got rid of that other h. Is that what you're asking about? Someone is asking why did I get rid of the h at the end? And the reason is because now I substituted in. Right? I got rid of the limit. I substituted the 0 in. Okay, let's look at one other type of thing that I'll see. And that's the following. Right? So let's say I've got 1 over 1 over x, like we do. This right here equals 1 times x over 1. Because remember, it's divided. So if I wanted to write it out like we did in grade school, and there's nothing wrong with doing that, this would be 1 divided by 1 over x. And that is 1 times x over 1, and that's simply x. Okay? 1 to 5, how do we feel about that? Oops. There we go. It's kind of got slow response on the Discord tonight. The poll is coming and coming and coming and coming. Okay. So that's really the point. I want to be able to recognize when these things happen, and I want to be able to deal with them quickly. All right. I just want to be able to recognize these little rules when they get abstract on me. Right? When I'm throwing around variables and stuff, I just want to be able to recognize the rules. All right. The other thing I want is the exponential forms of the fractions. Okay. So I want to remember that 1 over x equals x to the negative 1. Okay, and that x to the negative 2 equals 1 over x squared. Okay, how do we feel about that? 1 to 5. So I just remember that I've got this weird form. I've got these kind of things hanging around here that look like this. So consider the following problem. I've got 1. I want to take the limit as x goes to 0 of, let's see, I got to get it so that it'll wind up being 0 over 0. So this would be x to the x plus 5 to the negative first times times x. Well, that'll actually be okay. I'm going to make this be 0 over 0. What the heck? Let's just do it like this. Times x plus 2. Okay? And let's make it go to infinity. Okay? So it's important to note here, right? So I've got the limit as x goes to infinity of x plus 5 to the negative 1 times x plus 2. It's important to note that this right here, I can't do the FOIL thing with this negative exponent. This actually equals the limit as x goes to infinity of x plus 2 over x plus 5. Okay? And that, because I'm going to infinity, I can do nothing else matters. That equals the limit as x goes to infinity of x over x. Those cancel, and I wind up with 1 here. And so that equals the limit as x goes to infinity of 1, which equals 1. Okay, so 1 to 5, how do we feel about that one? As you can see, my battery's getting low. Let me make put the plug back in it. Okay. The other major problem I often see is this cancellation. So one other thing I just want you to remember. Remember, you can't pull out of plus. Minus. Let me show you what I mean by that. So let's say I've got x squared plus x over x plus 2. Okay? This is not, I cannot cancel this x with that x, right? I cannot cancel okay? Right, so I can't simplify this by canceling the x. There's no simplification to do here. 1 to 5, how do we feel about that? Oops, wrong thing. Likewise, consider x squared minus 4. And let's put something on top. Let's put x plus 2 over x minus 4. X squared minus 4. And we'll do the limit as x goes to 2 of this. Okay? Now, I cannot cancel that x and that x. Is everyone on board with this? I can't do that. I have to factor out the bottom. Okay? Now, I can cancel the group. Okay? And I would advise you to remember that this goes to 1. I need the limit sign. I forgot the limit here. Equals the limit as x goes to 2 of 1 over x minus 2. And then I'll just sub it in. And I wind up with this doesn't exist because this is going to go up 1 and this is going to go down 1. So the limit, so this part, the left bit is going to go to limit as x goes to 2 from the left of 1 over x minus 2 equals, so if I go from the left, this is going to be 1 over 0 minus, which equals negative infinity, and this is going to be the limit as x goes to 2 from the right. This is going to be a positive number on the bottom. Over x minus 2 equals 1 over 0 plus, because I'm going to have a very small positive number. That's going to be positive infinity, so this doesn't exist. Okay? 1 to 5, how do we feel about that? The point is, I can't cancel here. I can't cancel anything on this, and I can't cancel anything here until I actually factor it out. Okay, so that's the whole thing for tonight. Does anyone have any questions? Okay. Well, enjoy the rest of your holiday then. I just wanted to go over it real fast, and then, of course, this will stay on YouTube and stay on Twitch. So that if you run into any of these problems, you can just refresh your memory on fractions a little bit. Okay? Any other questions? All right. Well, good evening. And I hope that you enjoy the rest of your holiday. I'll see y'all on Wednesday.